Hey, hi. We are live, and I forgot to change my stream title. Advent of Code Day 3. Let me do that real quick. Advent of Code Day 3. All right, so let me do that. I forgot to do that. That's bad. And let me transition over to my screen. Okay, so hi and welcome to Advent of Code Day 3. I apologize if the stream alert was wrong. It was wrong. I apologize that it was wrong. Okay, let us look at our Advent calendar for Day 3. But before I do, remind me later. Before I do, I want to... what was my... Okay. We have to go through this process. What I did was I updated my terminal and now everything's wrong. So I need to fix that. So bear with me while I fix my terminal permissions here. If I quit and then restart, maybe that'll do the trick. Yeah, okay. So now it's working. Let me pull that over here. This is a sign that you're watching a professional streamer, where they do all of their stuff right here in front of you. Okay, so we're going to start another tab here. And that's for the server, and then let's make this bigger here. And then make it 100 columns wide. Like that. I'm sure there's an easier way to do that too. Let me refresh my chat to make sure I don't lose anybody. Okay, good. Again, hi and welcome. Okay, so what we're going to do is we're going to refactor. I'm going to start off by doing a little refactoring because we have code here in day 1 that reads a file and code here in day 2 that reads a file, and I'm going to bet dollars to donuts that day 3 is going to require us to read a file. So let's create a brand new utils rs and pull in that code that reads a file and returns a vec of strings. Right, and this is all we're going to do here. And we're going to change this to read file and give it a file name. A string maybe, although this is taking a stir. Maybe we just do that. File name. We change that. And then we don't do any of those. Okay, so this is our utility thing, and now we're going to need in main to include it, right? And then in day 1, let's see if we can use it. So we should be able to say use create, right? Utils, and now I forgot what I called it. Read file. Like that. And these go away. And then I could just say let lines equals read file inputs input day01.text. Right? Cargo check, and we get 2 errors. Help add a semicolon. Why do we need to add a semicolon? We're because I did a let. So we should be able to just get rid of that too and just say that, right? Will that work? That works. All right, and if I say cargo run, it should still give us the same values. Yes. Okay, I remember those values from last time. All right, and so we did that for utils. Now we just, for day 2, we'll do the same thing. They use create, utils, read file, get rid of those. Let read lines equals just read file, inputs input day02.text. And then that should work. And oh, I haven't set up my testing yet. I want to do that. What's it? Vim, after, FTP plugin, and then Rust. Right, I was going to set up leader T to be cargo test. Does advent of code build upon previous day's code, or is each day complete? That's a great project. That's a great question, Epic. Some years, yes. Like 2019 was all built around this int code. It's a basically a bytecode machine that you were developing over the course of several days. So maybe about half of the days you actually built an int code computer and you just extended it for each day to do more and more work. And then others like this, I mean, other so far these three are all, well, these first two are independent. We haven't seen the third one yet. But there's a mix over the years of some days where it builds on others and some days where it doesn't. So let me restart Vim so I can do cargo test day02. Okay, so the tests pass, but the tests don't read the file. Let's do that. Okay, and these numbers are exactly the same. Okay, good. So I think what we did was successfully refactor our code that reads the input. I'm going to get rid of these comments because they're not needed anymore. And I've got a feeling, I was thinking about this the other day, I've got a feeling that some of these mutes aren't needed. But let's get this working and clean the part 2 up as a separate commit. Refactor read lines into a utility file. Oops. I know there's a way you can do. I'm not a head source. I'm not a good Git user yet. I use Mercurial in my day job, so I'm still bumbling about. Regarding the to-do macro you mentioned yesterday, I was certain it was possible to provide it with a custom message, but it turns out I was thinking about unimplemented. Oh, okay. Well, we can use unimplemented. That was in the main project I'm doing here with the roguelike tutorial. Yes, I remember. Thank you, Epic. Okay, what are we doing now? Oh, I wanted to look at day02, right? And see if we can get rid of these mutes, because I don't think they're necessary. Types differ in mutability, right? Because it says mute here, but maybe we can get rid of those as well. We have 2 warnings, though. That's interesting. Maybe that's some more. Yeah, check. Yeah, so this doesn't need to be mutable anymore. Oh, because we're just reading all the lines. I mean, sorry, reading all the lines. We're not passing in a mutable lines list anymore, so that doesn't need to be. Perfect, okay. So that makes me feel a little bit better, getting rid of those mutes. And Clippy should be happy with that. Oh, it isn't. Oh, right, yeah, Clippy really likes doing this way, passing in vects. Slices instead of vects. So let me do that. And I gotta just remember it because otherwise Clippy's gonna tell me every time. Oh, come on. There we go. Sometimes my fingers get caught up trying to do secret VI commands. And you can't see what I'm doing, but that's all right. Okay, so git diff. Right, so we remove the mutabilities and we clean that up. So git add source, git commit -m day2 cleanup. Okay, so we are ready for day 3. Actually, almost ready for day 3, right? Because we have to modify source main to add day 3. Day 03, day 03. At some point, I'll put these in a vector and just loop over them and then check standard args or standard env args to see which one I want to run. But that day is not today. So we'll copy source. Oh no, make their source day 03. And we're going to copy source day 01 mod to day 03. And then we're going to use the wrong editor. That file, change this to day 3. And I'm assuming there's going to be an input. Oop. Let's get rid of that. These change to day 3. This change to day 3. We get rid of those. And I'm going to comment this out for now so that we can test. Yes, okay, so everything's working and we should be able to see, oh no, it didn't work because why? It should have complained. It should have had a compilation error because those increasing functions didn't exist. So this should fail, right? Oh no, there we go. Yeah, we're not using that. Okay. We're good. We're good. So okay, so now we're ready for day 3, right? And we can figure out what day 3 is going to be. And this should, well, it'll compile, but it won't blow up. Interesting. They're not getting a warning that we're not using lines. Something's bugging me now. I'm going to restart. No. I'm still bothered by this. Why are we not seeing any? Okay. I'm not going to worry about it till later. Let's see what day 3 has. A little too big there. Submarine has been making some odd creaking noise. That's right, we're on a submarine. So you ask it to produce a diagnostic report just in case. The diagnostic report, sorry, something's on my desk here that I want somewhere else. Okay, the diagnostic report, your puzzle input, consists of a list of binary numbers which, when decoded properly, can tell you many useful things about the conditions of the submarine. You have to use the binary numbers to get the gamma rate and epsilon rate. Each bit in the gamma rate can be determined by defining the most common bit in the corresponding position of all numbers. For example, this, right? And this is going to become our test input. Considering only the first bit of each number, all right, the first bit being the one on the left or the one on the right. There are 5 0 bits and 7 1 bits. Okay, I see 7 1 bits on the one on the left. So this must be the first bit is the leftmost bit. The most common second bit of numbers in the diagnostic report is 0, so the second bit of the gamma rate is 0. Okay, well that's going to be true. If these are bits, the second is going to be the opposite of the first, right? Most common value of the third, fourth, and fifth bits are 1, 1, and 0, respectively, so the final 3 bits of the gamma rate are 1, 1, 0. So the gamma rate is the binary number 1, 0, 1, 1, 0, or 22 in decimal. Okay, so we have to add up the number of 1s and 0s, and whichever one is bigger will get. Okay. There's 7, 8, 9, 10, 11, 12. There's 12 numbers in here, so, okay. So it could be an even, right? It doesn't say what to do if there's an equal number. If we have an even number of entries, there could be an even number of 1s and 0s, but I'm going to not worry about that. Mod tests. We'll cross that bridge when we come to it. Use super, : star. And then we'll write a test, and we're going to add all of this stuff in here. So copy, test, and let lines is equal to a vec of all of this stuff, right? So while I'm doing this, I'm trying to think about how we can accomplish this task. What's the easiest way to do this? right? We want to split it up by character and check the characters, right? So we want new lines on there to string, and then close that, and we'll just say assert EQ. I didn't keep reading, did I? What actually are we outputting here? The epsilon rate is calculated in a similar way. Rather than use the most common bit, the least common bit from each position is used. So the epsilon rate is 01001, or 9 in decimal. That's okay. That's just the inverse of this guy, right? So if we do like a not operation, we should be able to get epsilon rate without having to calculate them separately. And actually, now that I think about it, all we need to do is check how many ones there are in each column. And if it's greater than half, right, then if the count of ones is greater than half, so as I said, there's 7 in the first one. There's 7 1 bits. It's more than the 6, which is half of the 12 here. Then it's a 1. If it's less than half, then it's a 0. So we can kind of simplify things a little bit that way, right? And then epsilon rate is just the inverse of this guy. So we only have to go through this list once. And then we multiply the gamma rate by the epsilon rate and come out with 198. Okay, so this is going to be equal to, come on, over here. There we go. Part 1 of lines is going to be 198. And we have to write part 1. So let's write part 1. Oh, part 1 of lines. And I'm trying to also think at the same time about what could part 2 possibly be. And I'm going to preemptively do this as a vector string, like that. And it's going to return a usize, I guess. All right, so we want to know, how many bits there are, because I bet you the puzzle input is going to be wider than 5. Let's find out. It is wider than 5. It looks like 16, maybe? No, that's 6, and that's 6. So it's 12 bits wide and 1,000,000 lines long. Okay, so let's save that as input for day 3. And I just have to remember to copy that over. But it's 12 bits, and the test input is 5 bits. So we want to do it based on lines of 0.len -1 for the new line, right? So that's the bit width. And then we want to have a count for each guy. So, right, we want for each column has to have its own count. And so I'll just create we can do this, right? Bit width. Just create a vector of zeros of bit widths, and then we just need to count them. And I bet you we can do function composition. But I'm not very smart. I'm just going to do it iteratively because my brain works that way. So my day job is in C. So I think in C. So this is going to be a C-like Rust solution. But we do want each individual char. We're iterating over the lines. And the reason I put a dot there is because I'm thinking we need to do like map it into s.chars, right? We get each individual character, and then we look at each character in line.enumerate, right? And then we want to say if c.1 equals a 1, then count of c.0 plus equals 1. Well, we can make it a little more rusty, right, by doing a filter instead, right? I don't know if this is more readable or less readable. Val. There should be a tuple. We can say that, and then just say you know, val equals 1 like that, and then just do this. Will that work? See, it's this is bothering me that this is not finding errors here. Why? Yeah, so we have a bunch of compilation errors that we're not seeing anymore. Oh, this should be lines, right? And I'm not returning a U size yet. Okay. But why? I can try restarting Vim. Yeah, I've got day 3 in here. Oh, it's not showing up here. Oh, why isn't it showing up here? It's definitely there. Do I have to add it to Git files before it'll check it? No, that doesn't make sense. Okay, I don't know what's going wrong there. Okay, so for line in lines, and then C count. So if we have this, if we have the count of each digit now, so the first one should be 7. Let me do that. Println. I think I can just print this thing out using the debug formatter count, and I'll just return a 0 for now. Right? Right? And it's going to complain that I'm not using something, right? But that's okay. I just want to see. Let me do a cargo run here. And it panicked. Cannot find file OS. Oh, I gotta, yeah. Okay. And this I'll comment out as well. Oh, right, I want to run it with the test. So I'm going to copy this temporarily. And then uncomment this guy. Cargo check passes. Bothering me now. All right, so we got 75875. So is that right? We got 7 1-bits on the first one. Oh, it doesn't tell us how many there are. But anyway, this is greater than 6, less than 6, greater than 6, greater than 6, less than 6. Which is 10110. So that's working perfectly. Now we just need to convert it into a number. So how are we going to do that? And this is, we're calculating what? The gamma value? The gamma rate. So we're going to start with gamma is 0. And we're going to loop over the count array. We're going to, and because the first digit is count of 0, the second one is count of 1, and so on, we're just shifting up each time, right? So we shift gamma up by 1, and then we OR in the value is greater than lines.len. Let me pull that out. Let len equals lines.len. So if value is greater than len over 2, so we'll call it max. Max as U size, right? So this will change a true false value to a 1 or 0, and then we'll just OR in that bit. If it's greater than half, then that bit gets set, and we shift up to the next one. So now we should be able to println gamma and see that be equal to 22 in decimal, right? Gamma is 22. All right, so now we need to calculate epsilon. How do we get epsilon? And it's not gamma, but we don't have, I can't just say not gamma because it'll invert all the bits in gamma. We just want to invert the number of bits we have, which we have from bit width. Okay. So epsilon is going to be, I'm doing 2 parens because I want to subtract 1 from this thing. Right? We want to do that. And that what this will do is generate all 1s that's the size of the bits we're working with. Is this repeating the same song over and over again? Or the same 5 songs? That's disappointing. Okay, so once we have all of the 1s, now we just need to exclusive OR it with gamma, and that'll invert every single bit in gamma and give us epsilon. So now we should be able to just return epsilon times gamma, right? It says, what do you multiply them together, you get 198. All right, so we do that, and now our test should work. And it failed. Left is 0, right is 192. Oh, it should be 198. But why would this fail? We got a 0 instead of what we were expecting. Let's print out epsilon and gamma. Epsilon and gamma should be 22 and 9. 9 and 22, so it should be 198, and it is. So the test should run. Okay, now it passes. I wonder what I did wrong. All right, so we get rid of that. Get rid of the test window, and now what we're going to do is read in that file. Right? There's nothing left to do but actually try it out. Because our test passes. And I don't know, I don't get this cargo check thing anymore. I broke something. All right. So this is in downloads. Input day 03. And we're going to move that into inputs. And we're going to just give it a shot and see what happens. Index out of bounds. Len is 11, but the index is 11. Oops. Let's take a look at the input day 03 and see if there's something, because this is 12 wide, right? That's 6 and that's 6. And we're on line 17 where it failed. Yeah. So it shouldn't get to, Did this already strip the did I miss that? I do a line unwrap. That doesn't strip the new line, or it shouldn't. Let me print out that first line. Lines of 0. And see what that looks like. It should have the new line in there, right? And oh, it doesn't. It doesn't have a new line in there. Okay. That's good to know. I wonder why not. What am I doing that's getting rid of the new lines? So this test is completely wrong because should have done 2x, not 1x. All right, so now we need to fix this, right? And run the tests. The test still passes. And now we should get the right output. Okay, so we got the number 841,526. That's the right answer. Okay, good. I do want to get rid of the extra println. And is there any other cleanup we want to do here? Nope. Okay. Clippy. Yeah, I know about that. I know about that. Okay, I'm not worried about that. Git add source, git, and add input, git commit -m, day 3, part 1, git push. Okay. I'm going to introduce a syntax error here. I don't know what's going wrong with my cargo check. That's frustrating. Oh, it didn't save it. Oh no, it did. It did. Yeah. Okay, I'll worry about that after I finish part 2. So let's find out what part 2 is. Close this thing here. Continue to part 2. Now I'm worried. Oh boy, look at all this. Next, you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Both the oxygen generator rating and the CO2 scrubber rating are values that can be found in your diagnostic report. Finding them is the tricky part. Both values are located using a similar process that involves filtering out values and use until only one remains. Before searching for either rating value, start with the full list of binary numbers from your diagnostic report and consider just the first bit. Then, keep only numbers selected by the bit criteria for the type of rating value for which you are searching. Discard numbers which do not match the bit criteria. If you only have one number left, stop. This is the rating value for which you are searching. So we have to figure out what the bit criteria are. Otherwise, repeat the process considering the next bit to the right. To find the oxygen generator rating, determine the most common value, 0 or 1, in the current bit position, and keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with a 1 in the position being considered. All right. Start with all 12 numbers. I'm just going to, okay, the CO2 scrubber reading is the least common, so it's just the opposite. So I skipped over that. So start with all 12 numbers and consider only the first bit of each number. There are more 1 bits than 0 bits, so keep only the 7 numbers with a 1 in the first starting position. Okay. So now I get, so basically filtering out, so which one's more common? And then we take that list, so we're generating a new list based on that. And then so we're doing most of the work here. We just need to then use this count array again. Let's pull this out so we can reuse it each time. I wonder if there's an easier way to do that, because it'll do every bit each time. I'm not worried about speed yet, though. Until speed becomes a problem, I don't care if I'm doing extra work, right? So let's pull this out into its own function. Bit frequency. And we're going to just pass in lines, which is mutable references. A reference to string, and it's going to return except this is just this, and I don't think you can return. Oh, we can return a vec of usize, right? That's fine. And then just say count here. And then we just say, we're going to call bit freak count equals, let count equals bit freak of lines. And I wanted to hit Control D, but that's not going to work. So cargo run. Oh, we have to pass in the width. Okay, so that works. So we successfully refactored that. So for part 2, we're going to be reducing the list each time, right? So for part 2, we start with the full list of lines, and then we work our way through the width for I in. So we're going to grab the bit width again, 0 dot dot bit width, and then we're going to get the count. But then we're only going to consider the second or the ith element. If count of I, right, is greater than the max. Doing a lot of code repetition here. That's okay. Is greater than the max, then we're going to use all of the ones from that string. Otherwise, we'll use all the zeros at that position. We're going to generate a new list of lines. This is tough for a day 3 problem, huh? Yeah. This is just going to be the opposite, right? Oh, it's not the opposite. It's not the opposite. I was wrong. Oh, man. So maybe we just need to... So now what we need to do here now is select all lines with a 1 in the ith position. Else, oops. Oh, why isn't it like that? Else, we select all lines with a 0 in the ith position. And then we're going to redo this, right? Oops. The problems become more difficult day by day. For the most part, yes. They're a little harder on weekends because the guy who runs it, Eric Wastl, figures people have a little more time on weekends, so the difficulty bumps up. Then it goes back a little easier on Monday, and it slowly gets harder again as the week goes on. So it varies, and I don't know how he determines complexity, because this is pretty complex for a day 1. A day 3. Because what we need to do is loop over all these guys, right? For each bit. But that's what I'm doing here. For each bit and bit width, and we have to filter this out. We have to filter out lines and come up with a new set of lines each time. So we're going to say let mute lines equals lines. Can we clone a thing like that? You have to put it here, because then what we're going to do is we're going to change all of these. Let mute new lines equals vec string new. I probably have the syntax wrong there. Oh, maybe I can just do this. Vec string vec new. And then what we're going to do is loop over each line, ln lines. Right, because we can still do that, yep. Maybe like that, and then say new lines if lines and this is a string, so we should be able to say char at. Oh, I don't know how to do it. Maybe it's lines. Rust string char at index. That's a regular string. String from. Yeah, I'm not seeing a char at or a get. There's probably an nth. Char indices contains. Char indices is probably a, yeah. That's an iterator. Slice. Split end starts with strip prefix. We can do trims on it. That's matches, lines, len. We can get. This is going to be super slow, right? It returns a subslice of I. So I probably can get. Can I do a single get? Then new lines push L. Oh, this is L. And then down here we say new lines equals new lines. Right, and then we copy this and paste this. And this isn't going to compile for reasons. Oh, okay. We don't want to do it this way. Yeah. Everything blows up. Ranges of view size. Yeah. So I can't just get a single one, which is weird, right? Get unchecked. I say chars, that's going to be an iterator. So I can say chars nth. But that's got to be slow, right? Because we're creating an iterator each time. Oops, I forgot to call it. And it's not a found expected struct string found in ampersand string. And I can't push star, right? Because we'd be dereferencing. Oh no, it didn't mind. Expected string found vec. Help consider borrowing here. Is that going to even work? Because isn't that going to drop out of? Oh, that worked. All right, so option char can't be dereferenced. If let some no, that's not how you do it. Because this is some, so we can just unwrap it, right? Nope. Char can't be dereferenced. And now we have errors here, right? Move occurs because this is this, which does not implement the copy trait, but it does implement clone. This is sloppy, isn't it? Expected struct string found stir to string. Will that make a different version of it, or do I have to clone that as well? expected string found stir, try L2 string, and I did a to string, expected string found stir. I have to leave the clone in there? Why can't I? Why can't I do this? Let x equals string, x colon string equals star L. Let's try L.to string. And see if that line works, and then just push x. Didn't mind that. Dereferencing the stir or remove the star, you think? Okay. Like that. Okay, so now we have this, yeah, we have the issue with the borrowed thing doesn't live long enough. Okay, oops. All right, so let's make these the same. And then we'll figure out how to do this by cloning again. Nope. Creates a temporary which is free while it's still in use. Dang. All right. There should be a way to yeah, it might be because I'm doing a slice here. And let's just change this back to a vec so they're the same type. And that way I don't have to do this reference thing. I'll just do a move, right? That should be a move. Yeah, okay, so that worked. We never call part 2, but this compiles. Let's see if we can print out the lines each time through the loop for testing part 2, right? Yeah, let me pull these lines back for testing because I want to print stuff out, and it's hard to print stuff out when you're testing. There's a way to do it. There's a oops, didn't mean to do that. Okay, so we can say part 2 lines. All right, so I want to print these new lines out. Println. Let's see if this even works as a new lines. Yeah, getting Rust code to compile is often a good feeling. You're right. You're definitely right there. Although I wish it wasn't. Ooh, that's not good. It's empty. Oh, right. We're supposed to continue until it's empty, or until we're down to the last one, right? That's what it said. If you only have one number left, stop. Otherwise, repeat the process. So we're going to say if new lines. Yeah. Let's do this. Print this out. If lines.len equals 1, then break. Nope, I wanted a cargo run it. Nope. Okay, we must be removing too many. So I'm going to say less than 2 here. That way if it's 1 or 0, it'll stop. Okay, I thought it would stop. let me pipe it into head. Yeah, and then it panics. Yeah, we're down to 1 here. Why isn't it stopping? Did we do the right thing though? So the first one should be this, yes, 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 yes. The second one is this, and this, yes. In third position, all 3, so keep those 3. Oh. Oh. Oh, okay, so that's how it gets to be equal. Right? If they're equal, if count of I is less than max, then we do this. So we'll set lines as new lines here. I think this is what the bug is, and then otherwise we leave lines alone. What did I do wrong? Oh, else if. Still panicked and still did the wrong thing here. All right, so the second bit, right, we did that correctly. 0, 0, 0, 0. There are more 0 bits than 1 bits. Wait a minute. Oh, right. So 1, 0, 0, 0, 1, 0, 1. Right. So the 7 remaining numbers, there are more 0 bits than 1 bits, and so we keep just these. And then the third positions, 3 of the 4 numbers have a 1. So keep those 3. Oh, maybe that's what's happening. 1, 1, 1, 0. So then these 3 should be kept. Right? In last year's Rust survey, someone wrote Clippy for people who find certain emptiness inside when they finally get code through the compiler. Yeah, once you get everything working and then you run Clippy and then Clippy says, here's everything you did wrong. That's pretty funny. Thanks, Epic. What are we doing wrong here though? Because we are, so let me print this out. Println max equals this versus count equals this. And say max and count of I. Cargo run. So max is 6 versus count of 3. Oh, that's what we're doing wrong. We're not resetting max. Oops. Max needs to be set each time because we have different numbers of lines each time. The bit width stays the same, but we have different max each time. We're still panicking here. And now we're not. We broke the second one. Max is 6 versus count of 7. Right? And then so we reduced it to 7 here. Entries. Then the max, so now we have 7 entries. Now half of them is going to be 3, right? Rounded down, half rounded down is 3, but now we have the same number of numbers. Oh, because the count is 3. So I'm off by 1 on my count. 1. So the count is the number of ones. 1, 2, 3. That's correct. Oh. So we don't do it this way. This is a bug. I thought you said if they're equal. Right, fifth position are equal zeros and ones. Okay, let me read this again. The bit criteria is the most common value. If 0 and 1 are equally common, keep the values of 1. Okay. So this is where we keep the value. So if it's greater than or equal to max, then we do that. Okay. And we're still panicking. But I think we got this right, and we did not get this right. Second bit of 7, there are more 0 bits than 1 bits. Right? What am I doing wrong? So count is 3 because there's 3 1s, but there's 4 zeros. And if there's 4 zeros, then we want to keep this. So maybe this rounding error is throwing us off here. What we need to say is count times 2. No, that's wrong also, right? Because it's not going to be the maximum number that we get. It's going to be more than half. That's what you need is it more than half? Round it up, I guess. All right, so this is what I had before. If it's more than half, I guess, yeah, if it rounds down, then this would be equal. And we're still panicking, but now this is correct. Oh, and now we're panicked because we have a broken pipe. All right, so now we got this down here. So we're down to 1, and did we get the correct number? We did not. It should have been this one, but we chose this one. All right, so we got off by 1 errors everywhere then. Or maybe we're trying to be too clever with our counts. So we know the max. We know that count of I is the number of 1s. So max minus count of I is the number of zeros. We just do it that way. And for some reason my thing is not working. That's still not right. This should lines less than 2. Oh, I have to break loop. I have to, oops. The reason it's not working is because this is breaking out of the wrong thing. So 3DD and put it here, 3 like that. Okay, so this should break properly. Huh? Oh, because we're trying to use that. Okay. That's what the error there is. Okay, so it's almost working. Now it's stopping correctly. It's just picking the wrong one here. The max is 3. Count is 2. Because there's 2 1s in this position. And then in the last position, we have 1 and 1, so we should keep the 1. And we're keeping the 0. So maybe this is greater than or equal to, right? Yes, okay. So that's the oxygen generator rating. Now we have to check the CO2 scrubber rating, which is exactly the same code, except this is reversed. And I hate doing this, but I'm going to do it. Right? Start with all 12 numbers and only consider the first bit. There are fewer 0 bits and 1 bits, so keep only the 5 numbers with the 0. All right, so let's see if this also generates the correct sequence of events. Wow, this is ugly. It did not, because we have to restart with the lines again. And we're shadowing that here. So this is input lines. This will be input lines dot clone, and then we'll just set that here. Don't need to do that. Okay. Ugly, ugly, ugly. Lines not found in this scope. Oh, right. This is input lines. Oh, man. So we got this. All right, so now we're doing the wrong way this way. Let's see, the first position. So it should be right. That's right. That's right. That's right. And that's right. The next one is 1, 1, 1 and 1, 0, 0, and 0, and 0. Third position is equal number of bits. So find the CO2 scrubber rating, keep the number with the 0 in that position. Oh, okay, so the equal now goes to the other guy on the second one. Right, and then we ran out of bits. We did get the right thing here, but we kept going too far. And I don't get why, because we did hit lines len of 0. Print len, lines len, lines len. Oh. Oh, because we're going to go to bit width. Oh, right. Okay. So we do need to have this in here as well as there. That's annoying. There should be a better way to refactor that. But I'm doing quick and dirty now. I'm just trying to get this banged out, not make it pretty. I can make it pretty tomorrow. Anyway, so we came up with the correct number. Finally, get the life support rating, multiply the oxygen generator rating by the CO2 scrubber rating to get 230. All right, so now that we have the correct value, we need to convert it into a number. And we can parse binary, right? Rust parse binary string. Anything in Rust that'll do that. Yes. Okay. So that's pretty easy. And we'll just say let, and the first one is what? The first one is the oxygen generator is equal to lines of 0 dot. Oh. So this is new size from str radix lines of 0 to unwrap. And then for the CO2 is going to be the same thing, and then we can just return oxygen times CO2. And then get rid of all these printlns. Okay, and then we'll see if part 2 is equal to 230. Oh, I didn't like this. Expected stir found toString, help consider borrowing here. Okay. 03. Radix. So we'll borrow there, and we'll borrow there. Test passes. I'll clean up that in a second. Oh, right. And now I have to change this back to here. What are these? Cargo run. All right, we got a number. All right. Oh my goodness. That was I say that I'm not competing for time because I'm not, but I feel like, okay, I'm like right on the edge of getting a solution. So I'm just going to put the sloppiest code together that I possibly can. And I need to figure out why this is not working. All right, XXX. Yeah, it's not, for some reason, it's not doing a cargo check. It thinks everything is fine. And I'm not sure how I can get more detail as to why it's not looking at day 3. It's definitely looking at day, well, it was looking at day 2. If I open day 2, you know what? First, let's get this checked in. Let's clean these 2 lines up, get it checked in, and then I can try to figure out why my config isn't working. Right, so 32 and 65. These don't need to be mutable. Like that. And then what was the other thing it was complaining about? I'm not using read file, but now I am. Okay. So that's there. This is interesting. All right, this goes back to what you were saying, Epic. I got my code to compile, it runs, it generates the right answer, and now Clippy is unhappy. Change this to lines. Okay. It's saying do this. Oh, input lines to owned. Okay. Input lines to owned. And then it's saying all if blocks contain the same code at the end. Oh, right. That was when we had... all right, so what's the first issue is part 2 is using this, and we want to do to owned instead of like that, right? And we do to owned over here. And all of these if statements have the same code, and this is left over from the fact that we had a else if in there. All right, and then what was the other one? Okay, I did that. All right. So Clippy, and this doesn't have to be borrowed. Okay. I'm doing it here though. It's not complaining about that one. Yeah. Okay. Maybe there's something special about that one. I don't know. The test still pass? Test still pass. Numbers still be the same. The numbers still be the same. Okay. Day 3, part 2. And push that up. Okay, so now what can we do about refactoring? Or what can we do about this? Let me try day 2 to introduce a syntax error and see if that works. See, that blows up. Right? I fix it, do that. Day 03 mod, introduce a syntax error. And now it works? Oh my God. Okay, well, at least it'll make the refactoring better. So what can we do here to make this smarter? If we pull this all out, we have to pass in a bunch of stuff, right? We have to pass in lines and bit width and then return. So we're only passing in those two things, right? And then return. Do we need this here? These three lines, are they needed? Because if we're just doing this, right, we're just doing it one per. Do we have to go loop back is what I'm saying. Can we just go through all bit positions so we don't need this extra loop? Because we only do one pass through the whole thing. Right? I think that's true. And let's find out. Oh, you can't break from here, right? Yeah, okay, so that extra loop was unnecessary. All right, so that's the beginning of the cleanup. Check. Test pass. All right, so the next part of the cleanup is to figure out which way we're comparing. If we're checking the max or the minimum, right? Because this is what's changed. This is the only difference, is this line here versus this line here. And so one way to do that would be to pass in a Boolean saying which way to compare. And another way would be to pass in a comparison function. Which I know can be done, but I don't know how to do it. So that's going to be something I'm going to have to research on my own time. All right, so let's call this an Advent day. Make sure we're all good because we did some changes. Yeah, we got rid of those extra loops. Git commit -m code cleanup. Oops. And git push. All right, and then I am out of time. Wow, that took the whole hour and a half for me. Well, hour and 13 minutes is how long I've been streaming for. So I'm not going to get to do any roguelike tutorial today. That's unfortunate. But we got 3 stars done. There's our calendar. In 15 hours and 42 minutes, the next one unlocks, but I'm going to be asleep. Oh, let's check the leaderboards. Private leaderboard on Sam's. I am still 6th. Okay. Chael, I am 6th. Sensing a pattern here. On Toggle Bits, I am not 6th. I am down at 12th. Okay, so that's a multiple of 6. And then Prime, I'm probably really far down, right? I can't even see me. Should be easy to find. Oh, there I am. Ah, we broke the multiple of 6 thing. All right, I'm 21st. I'm in the top 25. That's how I count that. All right. Yeah, let's see. I don't think there's anybody. Just looking. Yep, Toggle Bit's up. Let's go raid Toggle Bit. But meanwhile, thanks very much for watching. And I will see you tomorrow. Oh, not tomorrow. I'll see you Monday. Sorry, I forgot today's Friday. All right, take care, everybody. Have a good one.